Good morning, ladies and gentlemen, and welcome to our new lesson for today, which is all about solutions, the properties of solutions, and the factors that affects the solubility of a substance. First, I would like to give you an overview of the objective for today, which is you're going to describe how solutions are formed, and you're going to explain the factors that affect the solubility of a substance. First, let's going to define solution. Solution is a homogeneous mixture wherein there's two or more substances that are involved. We call them the solute and the solvent. The solute is the one that is being dissolved in the solvent. Generally, the solvent is the one that dissolves the solute. For example, in this beaker of salt water, we have the salt as the solute, and then our solvent is the water. We call this aqueous solution if the solvent is water. Another example is when you dissolve sugar in a beaker of water. The sugar is your solute and the water is your solvent. So that's how a solution is formed, by combining two or more substances in order to form a homogeneous mixture. When we say a homogeneous mixture, that's only making up one phase of a solution, which means you only see one phase of the substances that are combined. Okay, if the solute is liquid or a solid and the solvent is water, we call that an aqueous solution. Okay, so solutions are not only liquid, they can be solid also. For example, we have in this bronze brush, they are actually made up of two or more elements combined to form a homogeneous mixture. See, as you can see, there's only one phase that you see in this example. Brass is a combination of copper and zinc, and we also have bronze, which is a combination of copper and tin, or we call it SN. So, and we also have a Gatorade. This is a liquid solution where we combine water, sucrose, and a little bit of salt. Okay, and we have the salt water, and NaCl, or the salt, and air. Air is a combination of different gases. So it's a mixture also. Like for example, nitrogen. There can be oxygen, and then there can also be carbon dioxide gas. So it's a mixture of different gases. Okay, and let's go ahead and talk about the three types of solutions. We call them unsaturated, saturated, and supersaturated solution. This would be a supersaturated solution. Okay. In an unsaturated solution, there's more solute that can be dissolved at a given temperature. Let's say, for example, we have a beaker of water. So I have here a beaker of water, and then we keep adding salt. Okay. So you keep adding salt and then you stir up the solution. The salt is dissolved in a given temperature of the water. So keep adding salt until there are no more salt that can be dissolved. Okay. So that's what we call as unsaturated. There are more solute that can be dissolved at a given temperature. However, as you keep adding more salt to the solution, you are going to reach a point wherein the salt cannot be dissolved anymore, and that becomes a saturated solution. Okay, because the as you keep adding more salt, which means there are now particles that are not able to be dissolved in the in the water, and that the saturation point has been reached. That means it becomes a saturated solution. Okay, and then when this saturated solution cannot dissolve any more solute at a given temperature, and you want to add more salt, what you're gonna do? For example, this is at 25 degrees Celsius. Okay, and then you want to add more salt to it, and then still the salt is not being dissolved. That is where you're going to form a supersaturated solution by increasing the temperature of this. For example, this is now 25 degrees, and then we're going to add heat. Okay, so we're going to add heat to this solution of water. Okay, so let's say we put the heat, add heat to let's say 35 degrees Celsius, and then what's gonna happen is the salt that is in here will be dissolved because of increasing the temperature. So once you increase the temperature, more salt will be dissolved. So which means you can add again more salt in order for the solution to take up more solute that can be dissolved. Okay, so as you keep adding more salt, the solution becomes a supersaturated solution because you can now add more salt in it in order for the solute to be dissolved. Okay, it's because of increasing the temperature. You know, this supersaturated solution, that is how they make rock candy. Okay, so the rock candy that you have in stores, they actually made that by supersaturating the solution. That means there's a lot of solute in the solution, and then when they cool off this one, when they cool off at 10 degrees Celsius, what's gonna happen is they form actually solids, like the candy solids that's actually the precipitate of the solution. So that's how you supersaturate the solution, by increasing the temperature so that you can add more salt, and then add more salt again until the solution becomes supersaturated. And then if you want to make the precipitate visible, then you're going to cool it down in order to actually get the precipitate. Okay, I have here a question for you. At a given solution at 25 degrees Celsius could not dissolve more solute. The given solution is an unsaturated. Is this true or false? It says here, could not dissolve more solute. So when you look at our definitions on the very top right here, it says here, a solution that cannot dissolve any more solute is saturated. So the given solution, it says here, is unsaturated. So which means this is false. This is false. Okay. All right. I have another one here. Let's take a look at this example here. So what is the same with all the test tubes that you'll see in the picture? As you can see, they have the same amount of water, but the difference is the color that they have. Okay, so this has darker color compared to this one, which is lighter in color. So this is lighter in color right here. This is lighter, and this is darker in color. Okay, although they have the same amount of water. Okay, so what might be the difference? Okay, we have what we call as dilute and concentrated solution. So in a concentrated solution, there are more particles of the solute. Okay, while the dilute solution, there's less particle of the solute. Okay, so as you can see here, concentrated, from the word concentrate, meaning to say there's more of the particles of the solute that is dissolved in the solvent. compared to dilute solution, which has less particles of the solute in the solvent. Okay, so as you increase the number of particles, as you can see in this picture right here, the more concentrated, that means there's more particles in the solution. The less concentrated, that means there's less particles in the solution, particles of the solute. That is why the less colored right here, that indicates there's less particles in this solution, which is dilute. We call it diluted, okay? And then the more concentrated gives you the darker color because of more particles of the solute dissolved in the solvent. It can be represented by this example right here, okay? So the darker the color, the more concentrated and the more particles on it. The the more dilute the solution, there's less particle that is in the solution. Okay, so we can define dilute solution as the one in which the amount of solute present is small compared to the amount of the solvent. And when we say concentrated solution, the solute is relatively large compared to the amount of the solvent. Okay, let's go to the factors that affects solubility. Okay, what are these factors that can affect how solute dissolves in a given solvent? Okay, let's take a look at this video so that we can have an idea of what these factors are that affects the solubility of a substance.
Factors affecting solubility. Why do aerated drink bottles open with a fizz? Well, in these drinks, carbon dioxide gas is dissolved in water under high pressure. When opened, all the compressed gas is released by the fizz. Let us learn more on the dissolution or solubility of substances in water. How does life underwater survive? Water is a liquid, and living organisms require oxygen, which is a gas, for breathing. Then how do they sustain themselves? Oxygen from air gets dissolved in water, and some of it comes from the photosynthesis of the water plants. So, the extension of dissolution or solubility is an important factor for life. Solubility is the measure of the maximum amount of solute that can dissolve in a given amount of solvent at a given temperature or pressure. Factors that have an effect on solubility are the nature of the solute and solvent, temperature, and pressure. Observe this demonstration. What can you conclude from the experiment?
So as you add more solute, as you can see in unsaturated, you dissolve more solute. Once you add more, then it becomes a saturated solution. Okay, you can dissolve more solute by increasing the temperature of the water solvent.
Click on the appropriate words.
An increase in temperature, blank, the solubility of a solid. So in a solid state, that means you need to increase the temperature to increase the solubility of the substance. So the solubility of solid is the opposite of the solubility of a gas in terms of temperature.
Boiled water tastes bland because dissolved gases like oxygen and carbon dioxide have escaped from it. The quantity of solute dissolved is expressed in grams per liter. This means that if one can dissolve 30 grams of sodium chloride in 1 liter of water at 20 degrees Celsius, then the solubility of sodium chloride in water is 30 grams per liter.
Okay, so let's discuss once again those factors that affects solubility. Okay, so as you can see, temperature affects the solubility of a certain solid. Okay, and of course a gas. Okay, so if you increase the temperature, you increase the solubility of a solid in most cases, except for gases. Okay, why? Because gases dissolve faster in lower temperature. Okay, so as you can see in here, exception to the rule is the gas. Okay, so more heat, that means less gas dissolves. Okay, as you can see here, this is an example of a fish kill in a lake. Okay, so what happened? Why there's a fish kill in the lake? If the temperature of the water is high, that means there's less amount of oxygen that is dissolved in the water. That means there's lack of dissolved oxygen in the water. That's why the fish died if the temperature of the water is high. But if the temperature of the water is cooler, or the temperature drops to a lower temperature, that means the more oxygen that will be dissolved in the water and more dissolved oxygen that will be used by the fish. Okay. Another example of this is when you try to put your diet coke or any of your drinks can drinks in can that is that you are drinking, you put them in the refrigerator, and then more gases will be dissolved on it. Okay, all right, so let's take a look at the effect of pressure versus solubility. Okay, as the pressure increases, the solubility increases. Okay, so let's say, for example, the sealed can, okay, of Diet Coke. Okay, so the more that is, the more pressure if it is sealed. Okay, so when you open the can, what happened is bubbles will come out because of the gases. Okay, the gases that actually are going to come out if you are going to open the can, because you are going to make the pressure lesser. Okay, so let's take a look at this syringe right here. Once you compress the syringe, what happen is there's more gas molecules that are soluble at higher pressure. So as you can see in this example here, okay, okay, as you can see in this example, as you compress, you are increasing the amount of pressure to the solution. Okay, so you're compressing here, which means you're actually increasing the pressure, and most of the gases are actually dissolved in the solution right here. Okay, so that's the effect of pressure on the solubility of solutes in a certain solvent. Okay, another one is agitation and solubility. Of course, once you have the solute in a glass of water, you can either shake it up or you can either agitate the solution in order to dissolve more of the solute. Okay. Another one is the surface area and solubility. Okay. How to make the surface area larger? By making the particles smaller. For example, these cubes of sugar, in order to increase the surface area, you have to break it down into smaller pieces, just like this. Okay. So the smaller the pieces are, the larger is the surface area and the faster that they will dissolve in as a given solvent. Okay. Another factors that affects the solubility is the types of solvent. As you may know, we have discussed before that like dissolves like. Okay, so meaning to say only a unique dissolves in a unique compounds. Okay, a unique compounds consisting of metal and a non-metal. Okay, so the positive and negative um charges of the elements. If you dissolve a unique with a unique compound, then they actually dissolve in each other, or we call them they are miscible. Okay, they actually miscible to each other. Okay, another one is polar dissolves in polar. So for example, any polar molecules can dissolve in any polar solvent. Okay, or polar solute dissolves in a polar solvent. And then we have another one, nonpolar dissolves in a nonpolar solvent. For example, oil and water. Okay, when you oil is nonpolar and water is a polar molecule. So if you combine oil with water, they're actually immiscible, which means they don't actually react to each other. They don't actually combine as one. Okay, because they're polar and non-polar. Okay, so the rule is like dissolves like. So it depends on the nature of the solvent. If the solvent is polar, then the solute should be polar in order for it to be dissolved in that solvent, water. Okay. All right. So these are the factors that affects the solubility of a substance. And another thing that I would like you to look at is the solubility curve. Okay. So as I have said, the temperature depends on either it is a solid or a gas solute. Okay. So as you can see on the solubility curve, the solubility of solid increases with increasing temperature. So once you increase the temperature, like let's say for example, this one KCl. So this is KCl. Once you increase the temperature, the solubility increases. The same thing with other solids like sodium nitrate, calcium chloride, lead nitrate, potassium nitrate, and then potassium dichromate, and cesium sulfate. Okay, which is in opposite to gases. Okay, if the solute is a gas, for example, carbon dioxide, nitrogen, oxygen, they actually dissolve faster at lesser temperature. So as you can see, once you dissolve helium or oxygen at lower temperature at 10 degrees, okay, they start to go lower. You see that? So the solubility of gas is actually faster at lower temperature. Okay. The same thing with carbon monoxide. Okay. Decreasing the temperature will increase the solubility. No, decreasing the temperature will actually um, increase the solubility. That's the thing. Okay. And then the same thing with CH4. Okay. Once you decrease the temperature, the solubility increases. All right, so let's try to summarize the factors that affects solubility. Okay, the first one is temperature. So the temperature depends on whether it is a solid or a gas. Okay, so if it's a solid, increasing the temperature will increase the solubility of solid. While in gases, it reacts the opposite way. If you increase the temperature, gas solubility will be lower. Okay, but if you decrease the temperature, the solubility of gas will be higher. Okay. In terms of pressure, there's no effect on solubility of solids or liquids, but it has a great effects on gases. When you increase the pressure, the gas solubility will also increase. Okay. And of course, it also depends on the polarity of the substance. When the solvent is polar, and the solute is polar, of course, the solute will dissolve. Okay, but if it is non-polar, it also dissolves in a non-polar substance. Okay, so it's based on the polarity of a certain substance. Okay. Aside from this temperature, pressure, and the polarity of the substance, we also have some of these factors that affect the rate of solubility. Okay, the first one is you stir the solution to, of course, dissolve more of the solute. Okay, for example, you add the salt in a glass of water, you have to stir the solution to increase the solubility of the salt. Okay, and of course, by increasing the surface area of the solute particles by grinding into smaller pieces. Okay, so the smaller the particles are, the faster they dissolve in a solvent. Okay, and of course, increasing the temperature and decreasing the uh, increasing the temperature and increasing the pressure. Okay, so these are the factors that affects the solubility of a substance. And if you have questions, please email them to me, or you can actually text me in reminder. All right, so your classwork will be in Google Classroom, and I hope you have a great day. Bye.